All right, here's our little mini lecture about aqueous reactions. We are skipping some material to talk about this. We'll eventually work our way back, but this is so that we can get a start on our net ionic equations worksheet, just so that we know what we're talking about. So when we're representing reactions, aqueous reactions in particular, so aqueous meaning that it's in solution, it's in water. Some of the things are going to be dissolved. We've got a couple of ways that we can represent our reaction. We've got a molecular equation. Our molecular equation is going to show the complete neutral formulas, pretending like things are molecules, essentially, for each compound. So every compound, every chemical, is going to have its complete neutral formula in the reaction. We're also going to have our little state signs after it. So as an example, 2 potassium hydroxide, aqueous, plus magnesium nitrate, aqueous, goes to 2 potassium nitrate, also aqueous, and magnesium hydroxide as a solid. That would be our molecular equation. Most of the time, we are going to look at the molecular equation. That's what we are going to see. It doesn't represent the reality. So something that presents a more realistic view is our complete ionic equation. Our complete ionic equation is still, it's complete, so it has everything in it. So complete includes everything. We're not cutting anything out. And the ionic part means that we're splitting aqueous chemicals. So anything that we have that AQ after, those are dissolved in solution. So if it's got this AQ after it, that means the cations, the anions, have separated in solution. They've been pulled apart, probably by the water molecules, and they're actually floating around as their own individual ions. So that's splitting the aqueous chemicals to ions. And then we also have the net ionic equation. And the net ionic equation shows us just what reacts. So if you've ever worked a job, if you've ever gotten a pay stub, if you've ever gotten a paycheck, if you look at the amount that they're supposed to be paying you, let's say you're making $20 an hour. If you're making $20 an hour, you're working 40 hours a week, 20 times 40, $800 a week is what you'd expect to see on your paycheck. That would be your gross pay, the total amount of money that's directed towards you. What you actually see, $600, $550, somewhere in there probably, that would be your net pay, the amount that actually makes it into your bank account, the amount that you actually get to spend. That's after taxes and other things, deductions get taken out. So our net ionic equation, we're taking some of the stuff out, just like your net pay has some of the stuff taken out. So what we're taking out is all the stuff that doesn't react. So for writing complete ionic equations, we need to break things down by whether they're soluble or not. If we've got aqueous strong electrolytes, these will exist as ions. Strong electrolytes fully separate or dissociate in solution. So they completely come apart. And my brain is having trouble spelling for some reason. Fully separate or dissociate. Let's try that again. All right, we did it. Me giving myself a high five. The insoluble substances, weak electrolytes or non-electrolytes. So weak electrolytes, things that don't completely dissolve. Non-electrolytes being things that don't have ions in them at all, so things like molecules, get written as molecules. anything with the solid, liquid, gas tag on them, those things stay as solid, liquid, gas. They stay as a whole and complete chemical formula. Weak acids should also be written in their molecular form, so keeping them together rather than separating them. For example, we've got lead 2 nitrate reacting with potassium chloride to form lead 2 chloride and potassium nitrate. Our complete ionic equation, we're taking everything that's AQ, which is most of it, and we're separating those into their ions. So our lead 2 comes out as Pb2+. Our NO3, our nitrate, separates out into nitrates. Notice that in our complete ionic equation, the NO3 minus now has a 2 in front of it. That 2 in front of it is because we had a subscript of 2 in lead 2 nitrate. So those subscripts will come out in front. For potassium chloride, we've got 2 potassium chlorides, so we've got 2 potassiums. We've also got 2 chlorides. So that distributes to both of those. On the product side, the right side, our lead 2 chloride is a solid, and so we just simply rewrite it as lead 2 chloride. And then our 2 in front of our potassium nitrate distributes again, so we've got 2 potassium ions plus 2 nitrate ions. And we're going to be writing a whole lot of AQs for these. Questions so far? So if it's got an AQ behind it, we're going to separate it into the cations and the anions. We might have to do a little bit of sleuth work, a little bit of math to figure out what our positive and negative charges are. So this is where it's very handy to have our ions memorized. So if you haven't started working on memorizing your ions, I highly recommend that you get started on that as soon as possible. Start working through that list of ions, including our oxy anions and some of our polyatomic ions. It's super helpful to have those memorized. It also means that you can, once you're good at it, you can just, like I did, read through this and come up with the names on the fly, basically at the same speed that you would normally talk. I don't expect us to get there, but that's the end goal if you continue to do chemistry. You'll get really fast with it. Okay, so that's our complete ionic equation. From our complete ionic equation, some of those ions do not participate, and the things that don't participate, like at a bonito bowl, for example, we would call spectator ions. Spectators do not participate, i.e., they just watch. They spectate. So anything that's the same on the reactant side, the left side, and the product side, the right side, we can remove. So the net ionic equation is shorter to write than the complete ionic equation, at least in most circumstances. So we're going to remove the spectator ions. And so then all that we would have left is our lead 2+, our 2 chlorides, and our lead 2 chloride as a solid. For our net ionic equation, just the things that actually react. So let's consider this reaction in aqueous solution. We've got hydroiodic acid reacting with barium hydroxide to produce water and barium iodide. We want to write the complete ionic and net ionic equations for this reaction. What are we writing? What are we doing to get to our complete ionic equation? If it's aqueous, we're going to separate it. So the H and the I go their own way. The barium and the hydroxide and the barium and the iodide all get split out for our complete ionic equation. This 2 in front of our hydroiodic acid is going to distribute. So we've got 2 H plus aqueous plus 2 I minus also aqueous. Our BaOH2 also gets split up. We've got a barium. Barium has a 2 positive charge. It's one of our alkaline earth metals. So it shows up in our second column, way down here, number 56. It's in our second column, 2A. It's always going to form a 2 plus charge. So Ba2 plus. This one's also aqueous. And we've got hydroxide. How many hydroxides do we have? 2 hydroxides. So 2 OH minus AQ. And that's our reactant side. Draw in our arrow. On the product side, we have 2 H2O. How do we split up H2O? We do not split up the H2O. Trick question. Why don't we split up the H2O? It's not aqueous. It's a liquid, so it stays as a liquid. But we have the barium iodide that gets split up. And I didn't quite space things correctly to get it all to fit in one line. So that's our complete ionic equation. Any questions about that one? On the worksheet, if you want to, I'll allow you to omit the AQs for some of them. Please write the AQs for some of them at least, so that you remember that you're supposed to write the AQs, because on an exam, if I ask you for a net, complete, all of it, ionic equation, I'm going to expect you to have the AQs behind things on the exam. If you can remember that you don't need them, or that if you remember that they're supposed to be there on the worksheet, you don't have to write it out 100,000 times. You can just write it out 5,000 times. Just on a couple of them. Okay, going to our net ionic equation. What do we need to change to go from our complete ionic equation to our net ionic equation? We're going to pretend it's sports in the year 2020 or 2021. We're going to remove all the spectators. So what was unchanged from the left side to the right side? Yeah, our spectators, we have the Ba2 plus. It's the same on both sides. And the 2 I minus. So we're going to get rid of those. So remove those and write what's left. So it's going to be 2H plus AQ plus 2OH minus AQ goes to 2H2O, L for liquid. And that, I think, is all we need to at least get a start on writing complete and net ionic equations. There are some other example types or some other equation types that'll show up on the complete and net ionic equations worksheet. But this gets us like the very bare minimum of what we need to at least get started. And we'll cover the rest as we get going through the class later in the week next week. One of those. Questions? Okay.